The very last section, 12.9, kind of summarizes the last few odds and ends that you need to know for this unit. The first thing that you're going to have to do is change from one form into the next. They introduced the very last form, which is called Intercept Form, and you're going to need to be able to convert this to find the vertex. And you're going to also use Intercept Form to find things called solutions or x-intercepts, and we'll talk about that in a second. We're also going to shift parabolas vertices either to the left or to the right, up or down. So the very first thing that they do is they start off with things that are in intercept form, or they ask you to put things into intercept form. This, number 2, is in standard form. The very first 3 problems say something like, rewrite the function in intercept form and then find the zeros of the function. This is not an intercept form. You're going to put it in intercept form. It's also known as factored form. So what does that mean? Factoring that we did a long time ago still comes into play. You're going to factor whatever they give you and put it into factored form. So this is where you go and you try to figure out what times what gives you the first thing. X times x gives you that first x squared. And what times what gives you 30 but will add, multiplies to be negative 30 but adds to be a positive 7. This is kind of like what I do with my Math 2 class. I do something like this where what multiplies to be negative 30 but adds to be 7. I'm thinking it has to do with the two numbers 7 and 10. Not 7 and 10, 3 and 10. Like 3 times 10 is 30, and if you do something, we can probably get a positive 7 out of that. If I put a plus 10 and a minus 3, that looks like it might multiply to be negative 30 and add to be a positive 7. Bless you. So what I would do here, if I had this in factored form, is I would factor it to x minus 3x plus 10. That multiplies to be that I can check by foiling and rewrite the function in intercept form. This is intercept form. This is what number 2 looks like. This is the first part of the answer for number 2. And then find the zeros of the function. Well, how do we find the zeros? We're going to use something called the zero product property. Where does this equal 0 basically? This is for the second part of the question. Where does x minus 3 times x plus 10 equal 0? Either the first factor equals 0 or the second factor equals 0 or both. And so if the first factor equals 0, then what would happen is you would add 3 to the other side and x would have to be equal to 3, or x plus 10 equals 0 and you would subtract 10 to the other side and x would equal negative 10. What are the zeros of the function? The zeros of the function are at negative 10, positive 3, and I usually put them in a solution set bracket. Those are your zeros. Those are your solutions. They're also where your x-intercepts are, but you would write them as ordered pairs for x-intercepts. So this is how you're going to do, I think it's 1, 2, and 3. When you get to the other questions, right in the middle of this whole 12.9 section, they're going to ask you to convert it from standard form into vertex form. So you're going to basically review 12.2, completing the square on the equation. Now I chose, and here are the steps. If you missed it on 12.2, the steps are right there. You move the c, you factor out the a if necessary, you add half of b squared, multiply by a if necessary, factor and get y by itself. I chose 2 examples for you for this. The first example has an a that's equal to 1, which is the kind of easy level. And then the second one I chose for you has an a of something other than 1. And so I chose number 8 because 8 has a fraction involved with it, and we'll do another one that has an a value. So here is what we're going to do for our first example. We're going to do numbers 8 and 9 together. Rewrite the function in vertex form. This is in standard form. We need it in vertex form. And then identify the vertex. So here's what we're going to do. Move the c. I want the c next to the y when I start this problem. Y minus 4. I'm going to subtract 4 and subtract 4. Equals x squared minus 3x. This is where you leave a little bit of space to work. Is the a value equal to 1? If it is, you can skip this step. Factor out the a if necessary. The a is a 1. We're totally fine. We can go to the next step. Add half of b squared multiplied by a if necessary. I'll explain what that means in a second. Add half of b squared. Here's b. Half of b. I'm going to add negative 3 over 2 squared to both sides. I'm going to add 9/4 to both sides. A negative 3 over 2 times a negative 3 over 2 is a positive 9 over 4. That's what I'm going to add over here. But on this side factors perfectly now. It turned it into a perfect square. That perfect square means that this is going to factor to x minus 3 over 2 squared. Just like we learned how to do in 12.2. The right side, on the other hand, we need to make sure that we put these together and that we have a common denominator. We have 9/4 minus 4. I'm just going to use my fraction button on my calculator, because I like how my calculator does fractions. It's kind of nice. That makes negative 7/4. And this is almost in vertex form. I want to put this k value on the other side. So I'm going to add 7/4 outside of the parentheses. I'm going to add 7/4, and I'm just going to go right to where my answer is, the part 1 of my answer. Rewrite the function in vertex form. There you go. We have now answered part 1 of the question. The only reason this was, why I chose it, was because this was an odd number. When it's an odd number, you have to divide by 2. Sometimes it doesn't go in evenly. What do? You just leave it as a fraction. It makes your life easier. Second part of the question, identify the vertex. I'm hoping you remember opposite, same. The vertex is going to be at the ordered pair. Opposite, instead of a negative 3 over 2, it's a positive 3 over 2. Same, 7 over 4. It's pretty easy to find the vertex once you have it in vertex form. Any questions? Ethan?
So calculator's going to be a Latin test?
As far as I know, yeah. Number 9. I also chose number 9 because it has an a value. So we're going to follow the steps that I had up here. We're going to move the c value first. I'm going to subtract 25. Y minus 25 equals 2x squared plus 24x. Now I'm going to do this slightly different than what I did before. My a value is a 2. That a value I need to figure out, it needs to be a 1. So what I'm going to do is I'm going to factor out the a value of a 2 here, which is going to change my b value. I'm going to do this just slightly different so you can see. I think it's easier this way. Factor out of 2. Factor out of 2. I'm pulling out a GCF of a 2 so that this will be a perfect square. Now 2 times this will equal that. 2 times the 12x will equal the 24x. Now I'm going to do this in a different color. And if this confuses you, then you can do it the same way that we do in 12.2. This is slightly different. This is where I look at b and I add half of b squared. I'm going to add 6 squared. That's the same thing that you've been doing. But what is different is this. Earlier, when this wasn't here, there was nothing there. I'm not really adding 36 to the right side. I'm adding 2 times 36. Over here, I'm not adding 36. I'm adding 2 times 36. This 2 is here because there's still this GCF out front. And earlier, it was a blank spot right there, and I'm not adding 36. I'm adding 2 times 36. Whatever I do to the right side, I have to do to the left, which is why in your directions I said add half of b squared multiplied by a if necessary. That GCF of an a, sometimes you have to multiply by it. That's where this comes into play. After that, everything becomes easy. Watch. Go switch back to red, Mr. Brahmo. If I can let it happen. Nope. Missed it. Got it. This factors perfectly to x plus 6 squared. That's the nice thing about that. This is multiply before you subtract. 36 times 2 minus 25 is 47. Positive 47. Y plus 47. All you have left to do is subtract the 47 to the other side. And you get y equals 2x plus 6 squared minus 47. And that is the first part of your answer. I think it's a little easier this way than the other way. The vertex, on the other hand, part 2 of the question, opposite, same. Very easy to find once you have it in vertex form. Could you divide by 2, divide by 2, divide by 2, and take the y and divide by 2? Yes. You'll get the same answer as long as you divide everything by 2. I think this way is faster. Here's the last thing that we're writing down in our notes. We're getting really short on time, so I may only get to number 13. Shifting parabolas. In vertex form, H is the opposite. K is the same. These 3 little dots means therefore. Therefore, shifts in the X direction need to be adding the opposite value to the H. Shifts in the Y direction add the same value to the K. So if we remembered opposite same, X directions, we're going to add the opposite value to the H. Shifts in the Y direction, add the same value to the K. I'm going to give you an example. Number 13 says, write the equation of the graph created when y equals x minus 1 squared plus 3 is shifted up 3 units and to the left 4 units. The long way is for you to find the vertex and then shift the vertex and then go and plug it back in. The shortest way possible to do this is to do what I'm going to do here. If I go left 4, that's your x direction. I just do the opposite of left 4. Left 4 normally means subtracting 4 in the x direction. If you do the opposite of that, that's where I'm going to put plus 4 underneath the h. Up 3 units normally means adding 3 units in the y direction. What I'm going to do is put plus 3 underneath the k. This is the shortest, fastest way to do the problem, which means your new vertex will be at -3, +6. Write the equation. This is the equation right here. This is your new equation that has been shifted left 4 and up 3. If you don't believe me, take this vertex, 1, 3. Take this vertex, -3, 6, and see, did it go to the left 4 units? Did it go up 3 units? And you'll see how it worked. The shortest, fastest way is to do opposite, same. And notice left and right goes with your x, and what do they give you first? The y coordinate, because they know some of you will mess that up. I do have one more example, and I just want to talk about it. I'm not going to solve it for you. It's number 18. It says this function may be formed by shifting this function which way? You have to figure out where the vertex is. You're going to have to convert this into vertex form first. And we're going to shift this function. It needs to end up with this vertex. So you're going to say whether it's right, up, down, left, or right. Factor it and then see how many units each one made when you make that conversion. We'll stop your notes right there.